Know your polyatomic ions, hint number 3. A lot of the time the polyatomic ions will stay together, so it'll appear on one side the same as the other. So if we keep them as one unit, that'll make things a lot easier. In our first example, hopefully we recognize the nitrate ion. Here we have AgNO3. On the left-hand side and on the right-hand side we have copper 2 nitrate. Notice the NO3 doesn't change. It's NO3 on the left, NO3 on the right. So instead of thinking, okay, I have one nitrogen here, one nitrogen, what we're going to do is say, I have one NO3 on the left, 2 groups of NO3 on the right. So now I know I need to put a 2 in front of my AgNO3 and a 2 in front of my Ag. Second example, same idea. I have 2 NO3s on the left, only 1 on the right. So I'll put a 2 in front of my KNO3. Now I have to put a 2 in front of my Ki. Gives me 2 Ks, 2 Is on each side, 1 Pb on each side. So now I'm balanced. Hint number 4, odds and evens. They will never balance out. If the total on one side is odd and the total on the other is even, try to double the whole equation. And that will allow us so that we can balance it. Let's take a look at our first example. 2 carbons. Put a 2 in front of my CO2. Put a 2 in front of my CO2. 6 hydrogens on the left. So I'll put a 3 in front of my H2O. Now if I count up my total number of oxygens, I have 4 from the CO2, 3 from the H2O, a total of 7. I need to have 7 on the left-hand side. Again, I only use whole numbers, so I can't put 3.5 in front of the O2. Right? Since oxygen always comes in pairs, I have an even number on the left, an odd number on the right. So what I'm going to do is I'm going to double everything. I'm going to put a 2 in front of my C2H6. That's going to change this to 4, and my coefficient in front of my H2O to a 6. So now how many oxygens do I have? I have 8 from my CO2, 4 times 2, and I have 6 from my H2O for a total of 14. Now since I have 14 on the right, I need 14 on the left, since they come in pairs, and now I can put a 7 in front of my O2, and that'll give me a balanced equation. Again, I couldn't balance it without putting that 2 in front. If you have odds on one side, even on the other, double everything. Next example here. I have NO plus O2 yields NO2. I have 3 on the left, 3 O's on the left, and only 2 on the right. So what am I going to do? Let's try putting a 2 in front of my NO. If I put a 2 in front of my NO, now I have 2 N's there. So I'll put a 2 over here. Now I have 2 N's on that side. I have a total of 4 oxygens on the left and a total of 4 oxygens on the right. Hint number 5, trial and error. Use a pencil. Sometimes it's just trial and error. Plug in numbers and see what happens. I'm going to give you guys a minute or two to try to balance these equations on your own. Why don't you pause the tape and try to write balanced equations. All right, let's look at the first one. Is there any trick as to what or which element to start with? Not really. It's trial and error. Let's say we're going to start with the chlorines. There's 3 here. Well, actually, I see that there's 2 arsenics over here. So let me put that 2 there first. Now I have 6 chlorides. I have to put a 6 in front there. That gives me 6 hydrogens. So I know I need to put a 3 in front of the H2S. That gives me 3 S's, 3 S's. So I'm balanced. Let's look at my second example. Fe 3O4, so let me put a 3 in front of my Fe. Now here my hydrogens are balanced, but my oxygens, I only have 1 on the left, 4 on the right. So I'll put a 4 in front of the H2Os. That'll make it so I have to put a 4 in front of the H2, and I can leave the Fe3O4 alone. Next one, Fe2O3 plus H2 yields Fe plus H2O. I have 2 Fe's on this side, so I'll put a 2 in front of my Fe over there. I have 3 O's on the left, so I'll have to put a 3 in front of my H2O, and a 3 in front of my H2. Last one. Now I see one of those polyatomic ions, NO3. I have 1 over there, 2 over here. So I'll put a 2 here. Now, for some reason, people have a hard time seeing this. The OH, I have 2 OHs and 2 H's bonding together. Can I think of HOH or H2O forming? Since I have a total of 2 O's and 4 H's, I can make 2 H2Os. So there's our hint number 5. Again, use a pencil and just try plugging in numbers. Finally, reduce when you are finished. Put all equations in their lowest whole number terms. So for some reason, you were trying to write the decomposition of water, and you got 10, 10, 5, reduce it. If they're all even numbers, reduce it. If they're all divisible by 3, reduce it. Before you are finished, do an atom count on each side just to make sure you're correct. Sometimes, again, you change one coefficient, and that's going to change something else. Again, it takes 2 seconds to go back over and look at it, and you might not be able to solve the problem if you have a wrong balanced equation. Practice, practice, practice. We'll be doing this all year. We'll be having starting off many problems in many different areas with just writing a balanced equation.